Welcome to the Agentic AI series, where we build one agent piece by piece across its whole architecture. In this demo, we cover the run loop, memory and state, and orchestration. This is the big one, because a real agent is more than a single call, it's a process, and that process needs three things. First, the run loop, or runtime, the engine that calls the model, runs its tools, looks at the result, and goes around again until the job is actually done, instead of stopping after one shot. Second, memory and state, the context the agent carries within a run and across runs, so it can build on what it already found instead of starting from zero every time. And third, orchestration, coordinating several specialized agents and steps, one to do the work, one to evaluate it, one to fix it, into a single workflow that drives toward a result. Put those together and you stop having a clever one-liner and start having a system. It loops, it remembers, and it coordinates. This is also why flow is the deepest part of the series. There's simply more machinery here than anywhere else, and it's the part that most looks like production. And that's the real lesson most people miss. An agent isn't one prompt in and one perfect answer out. A single model call is powerful but fallible, so you surround it several specialized agents that write, evaluate, and rewrite the loop, the guardrails and checks, the memory, the tools, and even a human in the loop rating the result so the system keeps learning. It was never really about the code. AI can write that now. It's about understanding the architecture, that a hard problem needs a coordinated system of agents. You don't point one agent at a difficult problem and count on magic. You build a system. Part 4, the summary. We're calling it complexity in a nutshell. This one isn't here to teach you another piece of machinery. It's here to show you how much of it there is, and why that matters. This is the payoff of the whole flow demo, and the driving message of the entire series. Let's start with what most people think an agent is. One box. A prompt goes in, a perfect answer comes out. Simple, clean, magic. This whole project is the proof that it doesn't work that way. Because one shot is fallible. A single model call is powerful, but it's unreliable. Ask it once, and the odds it gives you exactly what you need just aren't that high. And the harder the problem, the worse a one-shot performs. You can't point one agent at a difficult problem and count on a correct solution. So what changes the game? Everything around the call. Several specialized agents, one to write, one to evaluate, one to rewrite, one to translate errors. A loop that keeps going until the answer passes the threshold of acceptance. Guardrails and checks that catch mistakes. Memory that remembers what worked. A human in the loop rating, the learning loop. And tools that let the agent actually reach the real data. None of that is the model. All of it is the system around the model. Put those layers together, and this is the real machine. You come in through checks and guardrails. The orchestrator runs the loop across 4 agents: writer, evaluator, rewriter, and translator. There's memory on one side and a real database on the other. The human rating feeds back into the cache, creating the learning loop. This is a complex infrastructure. Now let me show you the real thing, the actual architecture, the way it was first drawn. Start with just the components and how they connect. The orchestrator in the middle. Readers and writers for the query cache and the external database. The evaluator and the writer down below. 9 moving parts, wired together, and we haven't even drawn the loops yet. Add the decisions. Does this query already exist in the cache? Is the score above threshold? Each one branches, yes or no, and sends the flow somewhere different. 2 decision points, 3 loopbacks, and suddenly the flow is doubling back on itself, again and again. Different colors represent separate algorithm loops. The cache lookup. The external database path. The no-cached query, go generate path. The evaluate path. The accept path. The rewrite loop. The save the winner loop. And we're still not done. Add the sub-evaluators and helpers, a syntax evaluator, a name evaluator, a score calculator, a best match picker. Now we see the full cast. All of this machinery stands behind one validated answer to one plain English question. AI can write the code, and that is not the hard part. The hard part is understanding how to use AI to produce reliable results. Knowing that a hard problem needs a coordinated system of agents that collaborate by writing, rewriting, rechecking. It is learning how to design a flow that works well. That is the skill. So here are the lessons of flow. 1 prompt in, 1 answer out is only good enough when precision doesn't matter. LLMs are non-deterministic by nature. The same question will usually give you a different answer. Similar, but not the same. One agent is never as strong as a team of agents, and the power grows exponentially. One agent might deliver a result with 80% reliability, but add a second agent as a quality check and the team performs at 99.9%. Agents are powerful, but fallible, so if you want them to perform well, you equip them with skills, checks, guardrails, loops, memory, and human feedback. Put it all together, and a lucky one-shot using a single agent becomes an infrastructure that reliably delivers high-quality results. You can point one agent at a difficult problem and hope for a correct answer, or you can build a system that works every time. The choice is obvious.
Thank you for spending time with us. Like and subscribe. Stay sharp, stay Azurite. See you in the next one.